25 years ago, not a single planet outside the solar system had been detected. But remarkably, we now know of thousands and have studied many in surprising detail. ESO's observatories in Chile have been at the forefront of this enormous expansion in knowledge, and their state-of-the-art instruments are continuing to discover and study the extraordinary diversity of exoplanets. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Looking up at the night sky, people throughout history have wondered if there are planets, and especially planets bearing life, beyond the solar system. Astronomers have also asked themselves these questions and many more. Are planets common or very rare? Do they resemble planets in the solar system, or are they totally different? Frustratingly, until very recently, observational techniques were not advanced enough to be able to answer any of these questions. But in 1995, this changed overnight. The first exoplanet orbiting a Sun-like star was detected. The monumental discovery was made by Geneva-based astronomers Michel Mayor and Didier Queloz around the star 51 exoplanet Pegasi. Named 51 Pegasi b has around half the mass of Jupiter and travels around its parent star in just over 4 Earth days. But this was only the beginning. The initial trickle of discoveries became a flood. Thousands of exoplanets have since been detected in a huge variety of sizes and orbits. Many of these discoveries have been made by ESO's observatories in Chile. But the hunt for exoplanets is a challenging one. These alien worlds hide in the shadows, giving off little or no light of their own. Any light that they do emit is swamped by the overwhelming brilliance of their parent star. However, advanced observational methods can be used to spot these elusive The weak gravitational pull of an exoplanet in orbit causes its parent star to wobble back and forth. This tiny motion causes a small shift in the star's spectrum, which extremely sensitive spectrographs, such as ESO's HARPS, can detect through radial velocity tracking. HARPS, installed on the ESO 3.6-meter telescope at the La Silla Observatory, is the world's foremost exoplanet hunter. It's the most successful finder of low-mass exoplanets to date. In 2010, the instrument discovered the richest planetary system yet. The system, located over 120 light-years away, around the Sun-like star HD 10180, contains at least 5 exoplanets. There is also tantalizing evidence that 2 more planets may be present in this system, one of which would have the lowest mass ever found. Planetary transits can also be utilized by astronomers to indirectly detect distant worlds. When an exoplanet passes in front of its parent star, as seen from the Earth, it blocks a small fraction of the star's light from our view. This creates a dip in the brightness of the star, which can be measured. In addition to determining the size of an exoplanet, planetary transits can reveal the composition of an exoplanet's atmosphere. The atmosphere around a super-Earth exoplanet was analyzed for the first time by astronomers using the Very Large Telescope. The planet, which is known as GJ 1214b, was studied as it passed in front of its parent star, and starlight passed through the planet's atmosphere. This starlight revealed that the planet's atmosphere is either mostly water in the form of steam, or is dominated by thick clouds. Directly observing an exoplanet is a monumental feat, but one that was first achieved by ESO. The Very Large Telescope obtained the first ever image of a planet outside the solar system. 2M1207b is 5 times more massive than Jupiter. It orbits a failed star, a brown dwarf, at a distance 55 times larger than the Earth to the Sun. ESO's telescopes are equipped with state-of-the-art instruments, but to remain at the forefront of exoplanet research, ESO has recently commissioned 2 new instruments for the VLT. Sphere is able to find and study faint planets masked by the glare of their host stars. And in the near future, the espresso spectrograph will arrive at the VLT, where it will surpass HARPS. The European Extremely Large Telescope, which is currently under construction in Chile, will take the hunt for exoplanets even further. Once operational, this 39-meter telescope could detect Earth-like planets and possibly evidence of alien biospheres. The search for planets outside the solar system constitutes a key element of what is possibly the greatest question of all. Is there life elsewhere in the universe? Over the past 20 years, our knowledge of exoplanets has advanced dramatically. But the quest for Earth-like planets and those that harbour life remains one of the great frontiers of astronomy. Are we alone? We do not know. But the answer is almost within reach.
A planet orbiting a star that entered our Milky Way from another galaxy has been detected by a European team of astronomers. The Jupiter-like planet is particularly unusual as it is orbiting a star nearing the end of its life and could be about to be engulfed by it, giving tantalizing clues about the fate of our own planetary system in the distant future. Hello and welcome to the ESOcast. In this episode, we're going to find out how an act of galactic cannibalism has brought a planet from another galaxy within astronomers' reach. Astronomers have detected nearly 500 planets orbiting stars in our cosmic neighborhood, but none outside our Milky Way has been confirmed. Now, however, a planet weighing at least 1.25 times as much as Jupiter has been discovered orbiting a star of extragalactic origin, even though the star now finds itself within our own galaxy. The star, which is known as HIP 13044, lies about 2,000 light-years from Earth and is part of the so-called Helmi stream. This stream of stars originally belonged to a dwarf galaxy, which was devoured by our Milky Way in an act of galactic cannibalism. Astronomers detected the planet by looking for tiny, telltale wobbles of the star, caused by the gravitational tug of an orbiting companion. For these precise observations, the team used a high-resolution spectrograph called FAROS, attached to the 2.2-meter telescope at ESO's La Silla Observatory in Chile. The planet, HIP 13044b, is also one of the few exoplanets known to have survived its host star massively growing in size after exhausting the hydrogen fuel supply in its core, i.e. the red giant phase of stellar evolution. HIP 13044b is near to its host star. At the closest point in its elliptical orbit, it is less than 1 stellar diameter from the surface of the star, or only about 0.055 times the Sun-Earth distance, and it completes an orbit in only about 16 days. The astronomers hypothesize that the planet's orbit might initially have been much larger, but that it moved inwards during the red giant phase. Any closer-in planets may not have been so lucky. Astronomers suggest that some inner planets may have been swallowed by the star during Jupiter-like exoplanet has escaped the fate of these inner planets so far. The star will expand again in the next stage of its evolution. When this happens, the star may engulf the planet, meaning it may be doomed after all. The astronomers are now searching for more planets around stars near the end of their lives. Their work may tell us about the distant fate of the planets in our own solar system as the Sun is also expected to become a red giant in about 5 billion years. This is Dr. J, signing off for the ESOcast. Join me